times 2/3, excuse me, negative 2/3 plus 5. This is going to be a negative number minus a 6, so that's negative. This is going to be negative 2/3 plus 5, that's positive. So between the two of them, they're not going to be 0. So this I know is not 0. What about with my 6/5? I have 7 times 6/5 minus 6 and 6/5 plus 5. This is clearly going to be a nice positive number. Yeah.
You're okay with us not actually finding
Yes,
it?
it's good enough that you can look at it and go, okay, definitely not happening.
Do we actually have to write it?
Yes. Because I can't read your minds to know that you've thought of it. What about this one? Let's see, 42/5 is around 8, so 8 minus 6, definitely not 0.
It's 12/5 times 31/5.
Okay. All I cared is that it wasn't 0.
Okay.
So my two vertical asymptotes are x equals negative 2/3 and x equals 6/5. And in web work, you write them in like this. You would write in x equals negative 2/3, comma, x equals 6/5.
I don't remember that.
Now, what about my horizontal asymptote? My horizontal asymptote always starts out as x approaches infinity. My function is going to approach something. What is it going to get close to?
Who knows?
Well, the numerator important will be the 7x, because the minus 6 doesn't mean anything, and the x, because the plus 5 doesn't mean anything. And my denominator, the important parts will be negative 6x, negative x, and what was the other one? 5x. So now when I simplify this, I have 7x squared over negative 30x squared. What happens to the x squareds? They cancel and become 1, so this becomes 7 over negative 30. As x gets really big, what happens to this number? Absolutely nothing, because there's no x in there to either make it get really big or an x somewhere to make it get really small. 7 over negative 30 gets to stay 7 over negative 30 for the rest of its life. So this is the number that I'm approaching. How do I write that as my horizontal asymptote? Y equals negative 7 over 30. It doesn't matter whether you put your negative sign on the top, bottom, or up front.
Because it will always be the same.
Yeah. It's not changing. All right, are we doing on time? Okay.
So we just so let me get this clear. So we just eliminate all the constants when we're trying to find the horizontal asymptote? Just all the time?
Not exactly.
I mean, because
Hang on. The constants we were able to eliminate here because they were small. But let's look at this one. And let's talk about what you would
I
think.
knew it was coming.
So when you're doing the horizontal asymptote here, the denominator, obviously, you can eliminate the minus 10. What about the numerator? What is important? What's the really major thing in making everything else be small?
The x squared.
Just the x squared, because if you think about, we're heading off to 100 billion trillion, or whatever, let's pick some huge number. Let's go for a trillion. A trillion times a trillion is really, really big, yes?
Yes.
But 9 times a trillion is going to be diddly squat compared to a trillion times a trillion, yes? So we can essentially ignore this piece, and ignore this piece because obviously 10 is nothing compared to a trillion.
So
What you're doing when it's all multiplied out is looking at really the leading term.
but it doesn't that mean it just has 2
To what?
asymptotes?
No.
No?
You can't have more than one horizontal asymptote.
Oh. Well, vertical.
Vertical asymptotes, you can have more than one. Horizontal, you're stuck with one. At most. You can have none. So now, go find out how many vertical asymptotes we have and how many horizontal asymptotes we have, and while you're at it, find the x-intercepts too. You can skip the domain and the y-intercepts.
Oh.
So vertical, horizontal,
Green Bay.
and x-intercepts.
Can't believe the Cardinals.
They don't want to talk about it.
What's 10?
X equals 10.
Right, I got that one.
Are we okay there? What?
No, because it can't equal 10 because that's a 0 on the bottom because it's undefined.
No, that's where
No?
I put it. Yeah, plug into the numerator.
Oh. That possible. 10 minus 10 is 0.
And when I do that, I get 10 squared minus 9 times 10 minus 10, which equals what? 0. If it makes both my numerator and my denominator 0, then it cannot be a vertical asymptote, so there are none.
That's what I thought.
The only option got tossed out. How about my horizontal asymptote? As f of x approaches infinity, f of x, what's important in the numerator?
X squared.
The x squared. So we approach x squared. What's important in the denominator? X. And how does that simplify? X. As x is getting really big, what happens to this function? It gets really big. You don't have a horizontal asymptote unless you are approaching a single number. That's not a single number. You just keep getting bigger and bigger. So there would be none for the horizontal asymptote. Yeah.
Why is it 9x important in the top?
Because when we talk about a trillion times a trillion, which is x squared, that's really big. 9 times a trillion isn't worth very much compared to that. It's all a relative term.
But well, what about dividing it by a trillion? Does that make it smaller? Yeah.
But so if we divided the 9x by 9 times a trillion by a trillion, that's just going to become a 9, so that's not going to be worth much anyway. So even if you kept, by the way, even if you kept the minus 9x part, when you simplify, you get x minus 9. And so you'd be going to something really huge minus 9, which is still something really huge. Yes?
Yeah.
So something really huge that just keeps getting bigger means you have no horizontal asymptote.
So if we end up with just x, we don't have no horizontal asymptote.
That's right, you have no horizontal asymptote if you end up with just x. Now, what about our x-intercepts? What did I do to find those? Set y equal to 0, so I have 0 equals x squared minus 9x minus 10
Right.
over x minus 10. And then what? Multiply both sides or by x minus 10 or cross multiply, and I would get what?
X squared minus 9x.
0 equals x squared minus 9x minus 10. Okay, so then I can factor x minus 10 times x plus 1. So I have x minus 10 equals 0. X plus 1 equals 0. This gives me x equals 10. This gives me x equals negative 1. What's wrong with x equals 10? It makes my denominator 0. Is that a problem? Yeah. Is there anything wrong with x equals negative 1?
No.
No. So this is no good because it makes the denominator 0. But this one you're okay with, negative 1, 0. By the way, had I made you find the domain, you would have already removed x equals 10, and so you would have said, oh, 10's not in the domain, so I can't have it. Now how much time we get out of it? Yeah, I got enough time to start